Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called X+X² by R squared. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Each line must be split into two parts, such that the digits on one side of the line must sum to x, and the digits on the other side of the line must sum to x squared. For example, a line may be able to be 4, 1, 3, 4, and 8. Or you could have 2, 3, 8, 9, 7, 1. Because 4 squared equals 1 plus 3 plus 4 plus 8, right? 1 plus 3 plus 4 plus 8 adds up to 16, which is 4 squared. Or you have 2 plus 3, which adds squared, which adds 2 and 3 add up to 5. So 5 squared is 25, which is equal to 8 plus 9 plus 7 plus 1. And digits may repeat on lines if Sudoku allows. So these are the examples that are given, which seem completely valid. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so that means each line, on one side they sum to x, on the other side they sum to x squared. So each line in total must be an x plus an x squared. So x squared is essentially x times x. If you factor out the x from both of the things, you have x times 1 plus x as a parentheses, right? So x plus x squared is essentially the same as x times the quantity 1 plus x. So that means when x is 1, you have essentially it equal to 1 times 2. If x is 2, it's 2 times 3, right? Because x times x plus 1. 3 times 4, 4 times 5, 5 times 6, 6 times 7, 7 times 8, 8 times 9. And I don't think anything's going to fit a 9 times 10. So that means the sums of the lines are going to be either 1 times 2, which is 2, but that's impossible actually for any length of line. So you can't ever have a 1 times 2, which adds up to 2. You could have 2 times 3, which multiplies to 6. 3 times 4, so you have 6 as possibilities. 6, 3 times 4 is 12. 4 times 5 is 20. And 5 times 6 is 30. And 6 times 7 is 42. And 7 times 8 is 56. And I don't think there's anything else here that can be larger than 56. We have 1, 2, 3, 4, 5, 6, 7. This is 7. This is 8, but this is all in the same line. Yeah, 56 is probably the largest, and I don't know if we're going to run into that. This could be 39 plus 9, which is 48. Okay. Or you could have here, this is 5, so it's 35, plus 8 and 9, which is 17. 35 plus 17 is 52, which is smaller than 56. This is 6 in size. 35 plus 9 is 44. 7 here. Okay, we have 7 here. So it could be 39 plus 9, which is 48. So yeah, it's the same as this. So this one is potentially the largest. So we have, these are the sums that each line could add up to. 6, 12, 20, 30, and 42, right? 6 is 2 times 3, 12 is 3 times 4, 20 is 4 times 5, 30 is 5 times 6, and 42 is 6 times 7. So those are the only possibilities we have for each sum, right? We've just tried out 7 times 8, and that doesn't fit any of the lines that are possible, right? The largest line we have is 8, and that's all in the same row, so that can't be more than 45. We have multiple 7s, but the one that is going to be the largest is 5 in the same box and then 2 in a different box. So that would be 35 at most here, and 17 at most, which is 52, but that's not even enough to get 56. And then the rest of the 7s are essentially just one extra digit, right? Because these are in the same box here, these are in the same row here, and then we have 6s, but that's not going to be that large. So these are the possible sums for every line. So what fits row 1? Because we have a single digit here, and then this line must add up to one of these sums. Well, it has to be 42, right? 30 and 15 as a single digit doesn't work. And then all of these are smaller. So it must be, this is 3, and this is 42, which is 6 times 7. That's 3 in the corner. We celebrate that. How about 2 sets of 4? So 2 sums. Oh. Interesting. There are multiple possibilities here. Interesting. Hmm. Okay, what about 6 digits? You can't have, so for this, you can't have 20 here. Huh. So let's make this smaller so that we don't confuse that. You can't have 20 here because that would mean 3 digits adding up to 45 minus 20, which is 25. And 3 digits add up to at most 24, which is 7, 8, 9, if they're unique. And you can't have 42 here. So this has to be 30 here, and this must be 15. So if this is 30, and this has to be 15. But there's a lot of possibilities. So we know this adds up to 15 here. I'm not sure if that's helpful, but we get something. So that's for 6 digits all in the same box. Let's see. For 2 sets of sums that add up, what are the possibilities? Well, 42 can't be with anything. 30 can be with 6 or 12. But the problem with that is if this is 30, this is 6 and 12. It can't be 30 and 12 because that would force us to be 3. But 30 and 6 could work. Okay. What about 20? 20 and 12 don't work. 20 and 6 obviously don't work. 20 and 12 don't work because that's 32 and the single digit can't be 22. So it could be, but it could be 20 and 20. So we have the possibilities of 30 and 6 here adding up, which would force us to be 9. Or 20 and 20 adding up, which would force this to be 5. Interesting. So we know this is 15 here. That doesn't help us much. How about here? So if we have 5 here, 5 or 9, that's going to be greater than 2 or 4, so it can't be 6. If it's 12, it could be 9, 2, 1. Or it could be 5, 4, 3. For 20, that works too. Okay, so... Wait, you can't have 30 and 6. There's no way you can have 6 here by itself, because 4 digits is not going to add up to 6. So it has to be 20 and 20. So this is 5 guaranteed then. It cannot be 9. Right, because if we have 30 and 6, the problem is you can't have 4 digits adding up to 6, right? It's minimum 1, 2, 3, 4, which is 10. So this has to be 15 here. 5, can you add up to 5 with 20? It would be 5, 7, 8, but you need a 4 on one end and 16 on the other end, which doesn't work. So it can't be 20, obviously can't be 30 for 3 digits. It can't be 6 for 3 digits because we have a 5 here. So this has to be 9. And it has to be 3 and 9. And 5 can't be in the 3 part, so 5 has to be in the 9 part. So it's 5, 4, and 3. Again, this has to be 30 because of the way that it's structured. So this is 15. So this must be 20 and 20. Well, the only way you add up to 20 is either 4 by itself. Sorry, the only way you add up to 4 is either 4 by itself or 1 and 3. Well, we have a 3 here, so this must be the 1, 3 that adds up to 4. And we need a 4 on this line. Cannot be here, so 4 has to be here. Again, this adds up to 30 here. This must be 15. So this is 4 here, and these 2 digits add up to 16. So it must be 7 and 9. And this is 4 here, and this must add up to 16, which is 2, 6, and 8. These 3 digits, again, must add up to 15, because this adds up to 30. It can't add up to 20, because if it adds up to 20, these 3 digits would have to add up to 25, which is too large. And if it adds up to 42, these 3 would add up to 3, which is too small. So this must be 30 and 15. Which means 7, 4, and 4 would work, but that's obviously duplicate. You have 2 4s in the same column. So it must be then 9, 4, and 2. Which means this can't be 2 here. This is a 6, 8 pair. This must be 7. So we have 4 digits here. Can this be 30? Maybe. This we know. Okay, so this has to be 5 times 6. Okay, what are the remaining digits here? The remaining digits here are 1, 2, 7, 9, which adds up to 19. 19 plus 1 is 20. 19 plus 11 is 30. So that doesn't work. So this must be 19 plus 1, which is 20. Which means we have 4 on one end and 16 on the other end. Well, 7 and 9 cannot be part of the 4 end. So 7 and 9 have to be here. Therefore, this becomes a 1, 2 pair, which forces this to be 2 and 1. Okay. Remaining digits in row or column 3 have to be 4 through 9, and these cannot be 4 or 9. This can't be 7. We know one of these ends must be a 5 to have 5 and x, 5 plus 5 plus 5 times 5 plus 1. So this is, one of these is 5, which means none of the rest of the column can be 5. What is this? We have 713, which is 11. 45 minus 11 is 34. If we had 30 here, the problem with that is that you can't have 4 for 2 digits here, right? So 34 minus 30 is 4. So that would be 4 there, but we have 1 and 3 already in the box. So this cannot be 30, it must be 20. Right? So since this is 20, 30, 40, this is 34 without the 317. 34 minus 20 means this is 14. So then this has to be 5 and 9 or 6 and 8 here. 4 has to be one of these two. And it would have to be that anyways. This is 7, 9, so this cannot be 7, 9 here. That makes that 2, 5, 6, or 8. Right? So it could be 259 adding up to 16, or 268 adding up to 16. Yeah, that seems like it works. This is 1. Remaining digits in row 9. It's 45 minus 12. So that's 33. 33 plus 9 adds up to 42. So this is 9, this is 7, this is 9. This must be what? Since this is 42, x must be 6. Well, this is not 6, so it has to be the other end. And you can't have 1, 2, 3 because of the 3 in the row. No 2, 4 because of the 4 in the row. No 1, 5 because of the 5 in the row. So this has to be a 6. Which means the remaining digits in that row are 1, 9, 2, 7, 8. We have a 1, 9 here, so this cannot be 1, 9 here. So this must be 1, 9 here. So this is 2, 7, and 8 here. We have 17 here already. That's going to be greater. So 45 minus 17 is 28, so it's less than 30. You can't have 5 digits adding up to 12, so this must be 20 then. So this is 20. That makes this 20 plus 37 is, sorry, 20 plus 17 is 37. 45 minus 37 is 8. So this is 8 and this is 6. That leaves the remaining digits here as 2, 3, 4, 5, 6. And it adds up to 20, so that means the x is 4. Well, you can only, again, to add up to 4, it's only 4 or 1, 3. We can't have 1, 3 here, so 4 has to be on the end somewhere. 2 can't be here because of the 2, 7, 8 triplet in the box. So 4 is either here, and this can't be 6. So one of these two is a 6 here. Remaining digits in row 7, we have 3, 4, 5, 7, 8. That's 3, 4, 5 is 12. Plus 8 is 20, plus 7 is 27. So we can get 3 to go up to 30 here, or we can get... Right, we can get 3 to go up to 30, and that's it. 27 plus 15 is 42. So this has to be 3, which means this has to be on this end. So it adds up to 30. So we have to have 5. Well, 3 and 2 doesn't work here. There's no 3, 1, 1 either possible. So this cannot be part of the 5 because of the 2 here. So this must be 5 here, which eliminates 5 in the rest of the box. That means this is a 2, 3 pair, which eliminates 2 and 3 in the rest of the row. So this can't be 2 or 3. This is 4. That eliminates 3 and 4 in the rest of the row. So this is a 5, 6 pair. And this must be 7 or 8. So this must be 3 and 4, and this can't be 3 because of 3 in the column. So that's 4, that's 3. Okay. This cannot add up to 12. And yeah, it can't add up to 12 because this is already 5 here. 5 plus 12 is 17, and 3 digits cannot add up to, which is 28. 45 minus 20, 45 minus 17, which is 28. So this has to be 20. Can it be 30? It could be 30. Well, hold up. Yeah, it could be 30. Huh. Okay. So it could be 20 or 30 here, right? So, is that right? 20, yeah, 20 works. Or 30 works, right? 3 digits. 35. I don't know if 30 works. 30, that means these 3 would add up to 10, right? Because 30 plus 5 is... One thing we know is 9 cannot be here. 9 can't be here because of 9 in the box. It can't be here because of 9 in the column. These cannot be 1. So 9 has to be one of these digits here. But that works if it's 20 or 30, I think. I think 30 is too big, right? 30 requires... If you had 30 here, that means this is 35 here. So this must add up to 10. You don't have 2 and 3. You could have 1, 4, and 5. But then the problem is this becomes 6, 7, 8, and 9. Right. Which is not equal to x plus x squared because you have an x of 5. So 30 does not work. Therefore, this must be 20. And the only way you can have 4 on either end, you can't have 1, 3 because of the 3 already in the row. So it has to be 4 here. And you can't have 9 in either of these spots. So to add up to 16, it would have to be 9 here, guaranteed. You can't have 2 and 4. It would have to be 1, 5. So this would be 1, 5, 9. Because you cannot have 4 here. You can't have 1, 3 here or 1, 3 here. So that forces the rest of the digits to be 6, 7, 8. So 25. Wait, that doesn't work. Oh. 159 is 15. It's 169 to add up to 16. So this is 169, which means this can't be 6. So that means this must be 5, 7, 8 to add up to 20. 5 cannot be here, but 5 could be either of these spots. We have a 5, 6, 7 quadruplet in box 6, which eliminates 5, 6, 7 in the rest of the box, so this must be a 1, 3 pair. This adds up to 16, so the rest of the digits add up to 45 minus 16, which is 29. Okay. And 29 can only add up with 1 to add up to 30, not 42, because it can't be 13, so this must be 1 here. So this is 1, which makes this 3, which makes that 1. Can you have... Well, so this can't be 5, because, again, this has to add up to 30, so one part must add up to 5. Well, so 6 is here. This cannot be 6. This forces a 4, 8, 9 triplet, which in column 7, which eliminates 4, 8, and 9 in the rest of the column. So this is 5, 6, 7, which eliminates 5, 6, 7 in the rest of the box. This can't be 5, 6, or 7. It's 8, which eliminates 8 here. That means none of these can be 8 here. Okay. This cannot add up to 5 because 1, 2, and 2 is a duplicate 2 in the row. 1 and 4 is eliminated because of the 4 in the row. So that means this end must be 5. Well, 4 can't be here, 4 can't be here. 4 has to be one of these two digits, which means it cannot be a 2, 3 pair here to add up to 5. So it must be a 5 here. So this is 5 and this is 4. Okay. What does that mean? That means where's 3 in this box cannot be here, so this must be 3. That leaves this as a 2, 7, 8 triplet, which eliminates 2, 7, 8 in the rest of the row. This can't be 7. This cannot be 7. It's 5 or 6. Remaining digits in row 4. We have 2 and 8 with one of 6 or 7. Okay, so again, we have sums that add up, so it could be, let's see, 6. Okay, this is not going to be 6. 9. Okay, where's 9? 9 can't be here. 9 can't be here in box 5, so 9 has to be here. That means we know what this adds up to. What does it add up to? This is 2, 5, 6, 7, 8. Cannot be 2, 7, or 8. So it's 5 or 6 here? Yeah, this is 5, 6 as a pair. We're guaranteed a 5 here. What is the sum of these digits here? 2, 5, 6, 7, 8. 2 and 8 add up to 10. 5, 6, 7 adds up to 18. So this is 28. Plus 2 digits with 1 and 1 would add up to 30, but you can't have 1 and 1 here. So it must be, this is 28. It must add up to, with 14 to add up to 42. So this is either 5, 9 or 6, 8. It cannot be 5, 9 because of the 9s in the column, so this must be a 6, 8 pair. That eliminates 6 and 8 from the rest of the row. We also have a 2, 5, 6, 7, 8 quadruplet in column 7, which eliminates, or quintuplet, sorry, which eliminates 2, 5, 6, 7, 8 in the rest of the column. This must be 3 and 4. This can't be 3 because of 3 in the column. So this is 4, which makes this 3. This must be, again, 6 and 6 squared. The only ways you add up to 6... You can't have 1, 2, 3. You could have 1, 5. You can't have 2, 4 anymore. Or you could have 6. Do we want to do that? I don't know. Guaranteed 5 here. So this adds up to 6 times 6 and 6 squared. Well, where can 6 be on the end? Can't be here, because it can't be 5, 1. And this is 7 for a single digit. So this must be 6 here, which forces this to be 7, 5, 6. That 6 eliminates 6 here, so it's 5 and 7. That leaves this as a 2, 8 pair here. 7 eliminates 7 here. We have a 2, 8 pair in column 6, which eliminates 2 and 8 in the rest of the columns. Can't be 8. This is 6, this is 8, which makes this not 8, so this is 2, this is 8. That eliminates 8 here, so this is 2. This can't be 2 or 8, so it's 7, which forces this to be 8. 6 eliminates 6 here, it's 5 and 6. Okay. 6 cannot be here. because of the 6-8 pair. Remaining digits in column 5. We have 1 and 5. This can't be 1 because of 1 in the row, so this must be 5, which forces this to be 1. So now you cannot ever have 1, 5, 1, 2, 3, or 2, 4 adding up to the 6 part. You need just 6, and 6 can't be here, so 6 has to be here. So this is 6 and 8, which eliminates 6 and 8 in the rest of the box. This 5 eliminates 5 here, so this is 2, that's 5. Remaining digits in column 4, we have 2, 7, and 9. Okay, this can't be 2, this can't be 7. And remaining digits in row 1 are 2, 5, 7, 9. But 5 can't be here and 5 can't be here, whereas the 5 in row 1, it has to be here. Okay, what are these digits? Remaining digits in row 2. We have 4, 6, 7, 8, 9. So we're guaranteed on this line to have 7, 6, and 8, which adds up to 21. 21, okay, this can't be 4, 6. 21 plus 4 at least is 25. So that could add up to 30, if that's the case. 7 with 2 and 3, or with 1 and 4. Well, it can't be 1 and 4 because you can't have 4 here. Interesting, okay. No 4 here. Again, 6, 7, and 8 is guaranteed here. That's 21. Plus 9 would be 30. So then this would have to add up to 12. Which it could be with 3 and 9 only. Okay. Remaining digits in row 3. We have 1, 2, 3, 4, and 9. Obviously, this can't be 3, 4. This can't be 4. So if this is 4, 6, 7, 8, which adds up 25, these two must add up to 5. And they do. That's 2 and 3. Well, what happens? So if to have 42, you need 6 at the end, right? This can't be 6, and this can't sum up to 6 either. So because of that, this cannot be adding up to 6 times 7, which is 42. So it must be 5 times 6, which adds up to 5 times 6 adds up to 30, or multiplies to 30. So this must be 3 and 2, which requires this to be 4, and then we have 6, 7, 8 here. That 4 eliminates 4 here, so this is 9 and 4. 2 eliminates 2 here, so this is 9, which makes that 7. This can't be 7 or 9, it's 8, which forces this to be 6. 2 eliminates 2 here. 3 eliminates 3 here, so that's 2 and 3. None of these can be, this can't be 2 or 8, so it's 7. This can't be 2 or 7, so it's 8. This can't be 7 or 8, it's 2. This has to be a 1 left. This is 7, 9 as a pair. That forces this to be 2. 2 and 7 eliminate 2 and 7 here, so that's 9, which forces this to be 7. 9 eliminates 9 here, so it's 1. This can't be 1 or 6, so that's 9. This can't be 1 or 9, so it's 6. 7 eliminates 7 here, so it's 8 and 7 because of 7 in the column. This 1 in the column eliminates 1 here, so this is 9 and 1. And you have the solution there. Okay. Yeah, fairly straightforward. Yeah. I think it was for me, it was very nice to have all the sum possibilities to be able to see them so that I could calculate and figure out what possibilities could be where, right? So that was helpful. Yeah, overall, pretty straightforward, a nice little puzzle. It does require a little thought behind it, which is, useful. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.